Okay, thank you. So we have been continuing this simple pendulum. So please see, look at the program again. So you can see this. We have already written the for statement, which will solve me for n steps. So now I want to visualize. So as you know, everywhere it is a plot command, right? So in MATLAB also there is a plot command. So what is the time? TME, is it not? And I want to plot with theta. Let us see what is happening. So after writing this, let me, I'll save it first. File, save, already saved because I have written alt fs. So then I will execute it. Execute it means I can execute it here either. I can run it from the graphic window. I can also run it from keyboard by pressing F5. I can also go there and type the name and run, but it is not required because you are becoming all GUI friendly. So better run it from here. Press F5 otherwise. It has come. So there is no error in the program. Therefore, you got the plot. Here it is the time x-axis and y-axis is the angle in radians. So let us say I want to plot it in red degrees. So how will plot, because we are more conversant in degrees. So write 180 divided by pi there itself. See. So again press F5. You got in degrees. So what is the amplitude you saw? Initial amplitude as 15 degree. You have given how much? Theta 0. Theta 0 to be 15. So it is oscillating between plus minus 15. Is it not? It is oscillating between plus minus 15. So let us now, I want to plot both acceleration as velocity as well as this. So in the same window, how I will plot? So I will create in MATLAB, there is something called a subplot. You can see this plot and subplot will be there somewhere in the graphics, 2D graphics. Go to graph 2D, help. See, this plot is there. You can see plot, help plot. There will be many things, but you are not interested in everything. So see plot, help plot. You got it? So these are different plots, different colors. You can create different things. So there is a more command already there. So you make it more off. If you make it more off, it will be better. You can see everything. So don't use these things because these plot commands which you see, these are the things which are coming from the toolboxes. So this is called overload. So they are not required right now. So just ignore them. Just see whatever is necessary here. It's a simple linear plot. You can see as a string made up of element. You can see you can plot colors. You can plot many things. Okay. In the same plot you can have it. So what are the related commands? There is something called a subplot. You can see this. These are subplot. Subplot means what it will do? It will divide the screen into number of small screens and choose a particular screen. So I am using that subplot. See, so I am interested to divide the screen into 2 cross 1. So I shall divide 2 cross 1 and I shall choose the first one to plot this, and I shall choose the second one to plot my velocity. This means the 2 comma 1 means I am dividing into 2 cross 1, and 1 means I am choosing the first 2 cross 1, then second I am choosing the second. So then I shall plot, I will copy it. I want to plot what? Omega, is it not? Is it not? And suppose I am interested to label the x-axis and y-axis. X, I will just write x label, time in seconds, and y label I can write theta or angle in degrees. I can write degrees like this. Similarly, here also I want to label x label. This is velocity, angular degrees per second. Okay, that's all. And one more thing which I have forgotten to tell you is the semicolon. After every command, every command line I have put a semicolon. What does it mean? If I put a semicolon, the command will not be echoed. the value will not be equal. For example, here I can see in this command, if I put suppose xs is equal to 2.3 without semicolon, it is equal. But I will put xs is equal to 5.4 with a semicolon, nothing will be equal. Similarly, if you can echo a command or echo not echo a command, so you can see help echo to see what is there, right? All right, so forget about it right now because you will come to know about all of them. So now I want to see this. Now you press F5, see what is happening. See, everything is here. Angle in degree. You can edit these plots. If you can edit these figure properties right here to change many things, change the attributes, change the, you can change this font of this, you can change, you can see. If I change the font size, I can change the color, many things you can do. So you can see, you can also change the color of this. If you want to change the color, solid line here, you double click on this, you can change the color, you can make it red. You can also change in the plot itself, so you can do many editing of this graph, okay, for your need. So this is all sinusoidal, it is fine, it is good. But suppose I will increase this theta, instead of 15, let me make it 50. You have not seen, this will become a nonlinear pendulum, did not? See what is happening. Still this is sinusoidal, you can say. It is oscillating sinusoidal, fine, it is good. But it is having a different property, period, okay. This is having a different property. It will depend upon the initial values. Suppose instead of k0, let us write 0.1. What is happening? Let us say. If I write 0.1, that means the friction is there. So now do it. You see, it is damping. It is damping. That means the amplitude is coming down. You increase this, make it, let us say 0.5. See, the pendulum is damping. So you can study many things depending upon this. Is it not? Now suppose I want to plot in different colors. This is different color, this is also a different color. Let us see. So what I shall do is, here only in plot I will change. So let us see, help plot. So go there. See what you want: blue, green, red, cyan, magenta. So let us say I am interested in red, R. So I was discussing how I want to change the line colors in the plot. So I want to make one of them as red, another maybe, let us say, green. And I want to also change the line width. So for line width or line size, if you want to know more about it, you go to doc plot. So in the doc plot, you see the different attributes of plot. You can see two-dimensional plot. Here you can see the line specifications. So if you see, if you go down, you can see that there is something called line size. Line specifications, if you go, you will find line style, line width. So all these things were there. So I can change it. So I am going to make it and see what I am doing. See, line width. You can see one example, line width 2. So, and I shall make it red. So here I shall make it, let us say, red, and at the same time line width 2. Here I'll make it, let us say, green, and line width 2. And I'll execute it. Let us see. There is only one plot I am getting. See what is the problem. Line size, I'll try. Line width. So line width 2. Okay. Is correct. Line width. And not here, sorry. It is not here. It will be in the plot. Right. So it should be in the plot. So here I want to make it green, there it is red, fine. So you can see, as I have said yesterday, that you have to specify the color as red, line width as 2. Execute it and see, you got it. Suppose you want to make it grids, some grids, you want to make grids in this graph, then you can here simply make grid on, that's all. Here also you can make grid on, execute it, you see you got the grids. So besides, you can also edit the graph right in the figure window. So this is called a figure window. This is called the figure window. This is an help window. I don't need help always, so I'll close it. And this is your editor where you are editing. This is a MATLAB editor where you can write your files. And this is the figure window, and this is the command window. There are various other windows. So you are able to manipulate with the graphs. If you want, you can save these graphs, file, save as. You can save the graphs in different files, either in fig file, you can also fig in different formats. So to save the graph in different formats, you have to do one export. So by exporting, that means you are trying to convert this particular figure into different files like enhanced meta files, JPEG, BMP, EPS, encapsulate PostScript, that is EPS, Adobe Illustrator, JPEG, TIFF, portable network graphics, paintbrush. So you have a whole range of graphic files where you can store this. So the inherent format of the MATLAB is .fig. So that will be a very compressed format where you can store the figures, right? So now you are able to manipulate with the plot. So let me go back, since this is the first class, this is the continuation of getting started. We have told many things, and we have also written a lot of commands, and most of them are not very clear to you. For example, I have opened an M file where I have written all these commands. These are very clear, but what about this? I am keeping some theta in parenthesis, I am keeping n. That is the way I represent arrays. This is vector. I can also represent multi-dimensional arrays in MATLAB. Similarly, so these operators and special characters which you have seen, they are similar to your C. The star represents multiplication, this represents the backslash represents division, this represents square, etc., etc. And one more thing which you did here is solving a differential equation in a very crude way. Is there any other better method for solving differential equation? The answer is yes. There are very elegant methods, and these elegant methods, as I have said, you have already saved these documents earlier in lecture 1. So you go to that document, you see under, see data function, function of function, fun, MATLAB fun, you just write help more on, then write help fun. You will find there are many functions which are there for optimization, finding 0 of a function, then numerical integration in different orders, numerically evaluate double integrals, function plotters, 3D mesh plotters, then differential equation solvers. The solving non-steep differential equation, medium order method, solving non-steep equations, solving steep differential equations. Then you have got delayed differential equations, boundary value problems, one-dimensional differential equation solvers. So there are different options which are handled by the option handling, so on and so forth. So I shall discuss about each one of them, and while discussing each one of them, since you may not be knowing what is a differential equation solution, how it is done, I shall be throwing some light on the different numerical methods associated with it. Because while doing so, while handling some of the functions like f-min search, for example, what is this f-min search and what does it this Neldar made direct search method? So I shall be while discussing about this particular method, I shall tell you what is this method. I shall just briefly highlight on this method so that you will understand what it is. So therefore, this particular course is not only related to MATLAB, it is also related to computational methods. So in the computational methods, I shall be discussing various kinds of numerical methods. So as far as general OPS operators and special characters, language, etc. are concerned, you are fine. but as far as the moment I start elementary matrix operations, elementary functions, you will be also fine. But specialized functions and matrix, numerical linear algebra, data analysis and Fourier transforms, polynomial functions, functions of functions, sparse matrices, so all the specialized graphs and graphics. So these things actually you need some other theory. So I shall be highlighting the theory as and when it is required. So now what I am going to do is I shall start with MATLAB general. I shall start bit by bit how exactly you will go about it. So I shall start with MATLAB general. So I shall not discuss anything further because we have already solved this simple pendulum motion. Then we have also solved for different values of damping coefficients. So let me stop here till I get back to this while again discussing differential equation solution. So what I am going to do is now I shall take the first directory of MATLAB and what are those general purpose commands. So let us go to help general. So before this help general, I want to tell you another thing. There is something called diary command. So this diary command is very beneficial because when you make this diary on, what happens, or diary a particular file name, what happens, whatever you do in MATLAB command window, that is recorded. You can see this is diary. So diary file name causes a copy of all subsequent command window input and most of the resulting command window output to be appended to name a file. So if you make diary a file name, you will find whatever you do in the command window, that will be stored. For example, let us say diary, I will write learn1.txt. Okay. So now let me do help general. See, so these are my commands. So I will take out one by one. So let me just browse through it. So you will find, so all the commands are there. So now I will make diary of. Now you will see in this particular directory, let us see what is there. You can write directory here. You will find there is a learn1, because this is the diary which you have given, learn1. It is a different name I have got. So anyway, so if you open this file, let me open this file. I can also open it from here. Open this text file. See what is there. You see whatever you typed in the command prompt, it is there. So in the command prompt you typed help this. So now I want to find the help of this. What are these things? So what is this help browser? Help browser will basically, if you type help browser, it will immediately go to the help browsing mode of, you can see, you just type help browser, you will know yourself what is happening. If you type, you see it is going directly into the HTML files which are stored in the help directory of MATLAB. So this is my first command. So let me go to the next command. So next command is doc. Doc, I have already told you, if you write doc a command name, it will show you the documentation relating to that command, right? Similarly help, also you know help. Help win also tell you, you can see help win, you write help win. See what is happening. It will, if you write help in a particular topic, it will be displaced in the help window again. For example, help, just write function, just write something called a function. You see help win function, right? So you got it. You see this is coming over here, our new function. This is telling what is help win function. So this is also similar to help browser. Now look for is a file to search for all. It's look for a particular keyword. If you give, it will look for all the M files. It will browse through all the M files in the MATLAB path. I shall discuss about what is MATLAB path and try to match that keyword if it is there in any of these M files, and those M files will be popped up. For example, you write look for Fourier, let us say. Look for Fourier, what is happening, you see, it will look for in these files. So you'll see in FFT, FFT2, FFTN, IFFT, IFFT2. So these files has got the keyword Fourier. So what is the advantage of this? So Control C, I have stopped this. So you can, the advantage is if I don't know about Fourier transform, I can look for where this Fourier is appearing. That means these are the M files which is there in the MATLAB path, which has got this word Fourier. What is the MATLAB path? You can see the MATLAB path here. You can open the MATLAB path. You can open the MATLAB path by set path. You can see set path. This is the MATLAB path. That means all these directories, whatever M files are there, if you type the name of the M files, it will search in all these directories and finally select a particular M file and execute it, right? So therefore, you can add or delete folders from this particular file. You can add your parent directory to this. So it will first always remember whether it is there in the path or not. The present directory will always be the first place where the MATLAB is going to search. So whenever suppose you type one word XYZ, what is happening? So it will first see whether it is an inbuilt command. Like inbuilt command is help is inbuilt command. Okay. So there is something called zeros. Zeros is an inbuilt command. Suppose zeros 5 6. What is zeros 5? It will give 5 by 5 zeros matrix. That means if you write A is equal to zeros 5, it will give you a matrix of 5 by 5. If you write A is equal to 0 5 by 3, it will give you a matrix of 5 by 3 all zeros. So these are called inbuilt commands. So it will first, if you type XYZ, it will look for whether it is an inbuilt command. If it is an inbuilt command, it will be executed, or inbuilt function, it will be executed. If it is not, then it will look for the present directory if there is an M file. If this M file is there, then it will execute that M file in the present directory. If it is not there, it will look for other directories. So before that, it will look for if it is an MEX command. I shall discuss what is MEX command later on. MEX command. I will discuss this MEX command later on. Anyway, so I was discussing about general. So I have seen these are the topics in general. So syntax, demo. If you write syntax, it will give you a lot of ideas on language. See, you can enter MATLAB commands. So this gives you syntax of how to write functions, how to write files. I wrote just one file for solving simple pendulum. You can write many things. So this gives you syntax basically. So most of these things you will not need. They are not very important. So if you write support, see what is happening. It will directly go to the support web page of MATLAB. I am not doing it. So you do it on your own. So what's new version will tell you the version of MATLAB. So those all of them except, I shall tell you, except this help, doc, help and look for. So these three I am just making it bold, or I'll just make it some comment. Control R, control. Okay, so this doc, remember this doc is important, this help is important, okay, then this look for is important. These three are important. So I'll write imp, this is important, so I'll delete everything else. This is not important. Only these important commands I am just keeping, because I have used, so I know what is important, what is not important. So this is not important, and demo is important, and version is not important always. Version and what's new. So these are only the important things I am keeping. The other things I am deleting. Okay. So doc, help, look for, and demo. Then comes the managing the workspace. First one was general information. So in the general information, only this is important. So this doc gives you documentation about a complete particular command. Look for searches for a particular keyword. Help is for helping. Demo is for giving you demo. So these are all important for this part. Let us look at, so this is important general. Okay. Then let us come to this managing the workspace. So workspace, as I said, once you are in command window, you are in a workspace. So there you store variables, different kind of variables. They may be numbers, they may be text, they may be strings, they may be complex numbers, they may be anything. So you can see, so these are my workspace variables. We have already executed. So I will try to over off because I want to see everything. So these are, if I write who, it will give you the workspace variables. So what are the workspace variables? L, A2, H, theta 0, N, A3, K, TME, but I want to know the nature of each of the variables. Write who_s. If I write who_s in the page 1, you can see L is just a single variable, N is a single variable, 1 cross 1 means single variable. As you know, in MATLAB, everything is dependent like an array. So A is a 5 cross 3 array, A1 is a 1 cross 1, that means a scalar. So answer is 5 cross 5, something I have typed. Omega is the speed, theta is the angle, position or the angle, theta naught is the initial value, this is the time. So these are the workspace variables. So by writing who and who is, you can know the list of current variables. So they are important. Workspace, if you type, it will show you the workspace in the window form. You can see this is the workspace which you get all the variables. This is also important sometimes, but as you grow in experience, you do not need to open so many windows, because that will create less space here and you cannot operate. So I better prefer not to use all the windows. So this is the workspace window. So this is not important, I should say. To me, it is not important. Clear, it is important. As I have said, clear all variables. You write help clear to know more about it. So this is called help clear. You can see. So there are different versions. If you write clear particular variables, it will clear the particular variables. If you write just clear, it will clear everything. If you write clear global, you will find there are certain variables called global variables, which is true for all the functions. So there are something called local variables. So local variables, as you know from your earlier programming language experience, global variables is true for all the subroutines and all the functions, and local variables are true for that particular function. Similarly, here you can write both global and local. So this declaration will be there. As you will discuss different examples, you will find this declaration is possible. So you can also clear all functions. If there are any function which has been compiled, you will find there are sometimes you need to compile the files, same files, to make exe files. So these functions can be cleared. Clear all means it will clear everything, all variables, including global variables, functions, everything. So most of the time you need this clear all or clear some variables. For example, let us write. So suppose these are the variables, I want to clear only particular variables. Let us say I am clearing A1 and A2. See what is there, who again, because A1 and A2 are gone, right? So if you write clear all, it will clear all the variables. Is that clear? Okay. So clear is also important. Pack. So what is pack? Pack will sometimes, what happens if you have a computer which doesn't have a lot of memory, and you write so many variables, that means the computer memory is jammed. You get less memory for operation. So if you write pack, it will compress the variables and keep it for future use. That means it will make available lot of memory space. So you can see what is help pack. So consolidate pack performs memory garbage collections. Extend MATLAB sessions may cause memory to become fragmented, preventing large variables from being stored. Pack is a command that saves all variables on disk, clears the memory, and then reloads those variables. So this is a good idea to pack. That means it will first store in a part of the disk, then clear the garbage, then come out. So this will not be again required, because nowadays you are using very powerful computers. Most of you must be having Pentium 4, because P3 by the time it is outdated, this is completely outdated from the market, you would like to have a new. So pack also will not be very important. So that is also I am deleting. But you will find these two commands, load and save, will be very important. I am writing important only. You can write down what is important in your notebook. So load and save, these will be very important. As I said, suppose you have certain variables here. Suppose you have certain variables like this. These are the variables which you are having. So I want to store these variables in a file. Where do I store? So you can store all the variables, or you can store some of the variables in a file called mat. It is a file which is a compressed form of data file which is understood by MATLAB only. You can store and save, and you can also load from the mat file. Other than that, you can also store the variables in the text files or ASCII files, American Standard Code for Information Interchange. So you can see help, save. So in the help save, please do not, these overload methods, do not worry. These are actually, this comes from different toolboxes where you got also save. These things you please do not worry right now. I shall get back to them later on. Okay. So in the save, you can see, you can save file name. You have to give them a file name, and the file name extension automatically becomes .mat, right? So while saving, suppose you want to save file name X, you will find a particular variable, suppose X, Y, Z, 3 variables I want to save. What are the variables? Let me see first in my command window. So who, these are my variables. Suppose I want to save theta, theta 0 and TME. Okay, so or save A3, some give a file name. So I am writing a file name, let us say junk1. So I want to store A3, then I want to store theta, and I want to store, let us say, omega. So it is saved. So how to know whether it is saved or not? You can see you have got junk.mat, which is saved here. There is another command to know what are the m files and mat files in the directory. That is called what. If you write what, it will show you the m files, and this is the only mat file which is there. So if you clear those variables which you have saved, what have you saved? You have saved A3 theta omega. So you clear A3 theta and omega. Here don't put comma. Remember, you have to give space. So you can see those variables are not there. A3 theta omega is clear, but it has been stored in junk1. So what you can do is you load junk1. If you load junk1, it is again there. So that means whatever variable set there in junk1, it is loaded. So there are different versions of help and save. So you can see save, if you can see. So you can also save in ASCII. I shall tell you just now how to save in ASCII. You can also save in a file which is already there. You can add new variables to it. Suppose there is junk1, you want to add a new variable. Okay, without overwriting, I want to add a new variable. So what should I do? So in that case, you please see, you have to give this append. That means you have to give the file name, then append, and then variables. For example, here, so in the junk1, I want to append this L. So what should I do? Save junk1 append L. So now if you clear L, along with this you also clear L, you find it is not there, then load junk1, you will find it is there, it has come. So all these variables are, you see, you are able to get these variables again back. You can add to this present variable. Similarly, you can also load. So load has also got different options. You can directly load the file name, just like I load. You can also load particular variables. You need not load every variables. For example, you can go to load junk1. You can load only L, let us say. It will be loaded. Only L will be loaded. Everything else, other things will not be loaded. So now it is as far as mat files are concerned. Let us discuss about ASCII files. What is an ASCII files? If you open an ASCII file, you will find columns of them. In a notepad, if you want to open an ASCII file in a notepad, you will find different columns. So therefore, the fundamental thing while storing in ASCII files is this. You should have column vectors first of all, and they should have same length. Only then you will be able to store them. For example, you can see here. So these are the ASCII files. It is not written here, but you have to write like that. Otherwise, you will not be able to save. For example, here I have got omega and theta. They are all row vectors. First of all, I want to make them column vectors. So making column vector means I want to make a transpose. Remember how I have made a transpose. So I am put a semicolon, omega dash. So I get a column vector. Theta again, theta dash. I get a column vector. So if I write omega, it is a column vector now. If I write theta, that is all column. So I am, you see, omega has become a column vector. Theta has also become a column vector. I want to make time also as a column vector. So make it time is equal to TME dash. So TME also has become a column vector. Now I want to store all of them in a file, let us say in junk2.ascii or txt. So how should I do? So what I am doing is, you can see, save junk2.txt, right? So I will write file names. What do I want? I want time first, followed by theta, followed by omega. Then I will write minus ASCII. It is saved. You can open this file. You can also open this from here. Junk2.txt, you see. All files, you write open all files. Junk2.txt, you see. No, no, it is not saved like this. I have to TME theta and theta. So I made a mistake because so that means there is a problem here, omega, right? So I need to save like this. I have to make a square bracket so that it goes in the form of a matrix. Let me make it. So I'll create a matrix like this, TME, theta and omega. So X is a matrix now. So now I'll save like this, jonc2 dot txt X. I'll apply an extension this. So now let me open this jonc2. I'll first close it. So now I'll open this jonc2. Let us see all files. You see, in the 3 columns I have saved it. It is very easy. So you want to save in 3 columns, then all the vectors should have same dimension, and it should be column vectors, and therefore this will be easily, this can be transferred to Excel or any other compatible file. If you want to save just like that, suppose I want to save let us say theta, and I will create a file jonc3.txt. I will save theta 0, then n, then k, followed by l, like that. So in that case, what will happen? They will be saved one after the other, and you have to figure out what is what. So if you open jonc3.txt, see what is happening. So first it is theta, then you will find followed by, you see, followed by this is what you have, followed by theta 0. So theta 0, this is followed by theta 0, then followed by n, k, l, all are ASCII. So this is how you have to figure out how much is, where is what. So one after the other, everything is same. So anyway, so you can save in ASCII, you can save in columns, but the easiest way to save identical vectors or vectors of same dimension, put them in column, make them a different vector like I made it like now. It is a 3 column vector. You can see how did I make it. So you see, this first of all, this time, theta and omega are of same dimension. So I want to create a matrix like this. First column will be TME, followed by theta, then followed by omega. So I'll start with a square bracket. TME is a vector which will come in the column form, then followed by theta, omega. So I got it. So X is a vector. If I want to know the size of X, X is a matrix. If I want to know the size of the matrix, you see it is a 600 by 3 matrix. So that is all about save and load. So this you can save in ASCII. You can also load from ASCII. Suppose you want to load jonc2.txt. So if I want to load jonc2.txt, you have to just give an ASCII extension. Sometimes in higher versions it is not required. So you'll find who are the variables. You can find, suppose you clear everything, clear all, let us say. Now you load, let us say, jonc2.txt. You see what is there. You got this jonc2 variable. That means whatever is stored in jonc2, whatever is stored, there is no variable name. So that all those things will be equated to jonc2, right? So that is why while saving in a particular ASCII file, you have saved in the form of a continuous columns. One column, next column, third column, fourth column, like that, one after the other. But when you load from an ASCII file, you will find all these things will be equated to a matrix whose name is the first name of the initial name of the file. For example, you see jonc2. So when I loaded, whatever was there in jonc2, that is equated to a variable named jonc2. Is that clear? So this is all about. So if you have any doubts, you can say, you can see help load, you can see what is written there, you can know more about it. Is that clear? So I have told about load. Now let me open that file where I have saved that diary. So all files, you got this Leran 1. So I got this load save, which is important. Quit means you are executing a MATLAB. So these are all important MATLAB commands. You have to learn this. So these are the important in general. This is important for managing the workspace. Then what is important here? Let us see. So here what tells you, what is also important, because what tells you what are the M files and MAT files in your directory. It tells you exactly simple pendulum, which we did earlier. This is the M file, .m file it is telling, and junk one is the MAT file. So what is also important? Type. This is not important because you don't want to list M file in the, if you type, you can see type, if you type simple pendulum 1, it will type the M file on the command prompt. This will not be required because you have a very beautiful editor, you can directly open there. So this I am not considering to be important. Edit. Suppose you have same thing, instead of this you can write edit, it will open the M file in the MATLAB editor. That is also not required because you can use directly, you can go to GUI and open from here. So therefore that is also not considered to be important for me. So I will just open it. Okay, so this edit also is not required. Open files by extension, this is also not required. You can see what is open, help, open, sorry, help, open. See what is happening. So you see help, open, what does it do? So it opens a variable. Suppose you open a variable, open a figure, open a MAT file, open a model, open a file which is having extension P, or open an HTML file. So this will be required. For example, here, okay. So I want to open, let us say, junk1.mat. What is happening? Let us see. So it is telling you what exactly is there. So if you see, there is a theta which is a double. So these are all there in junk1. If you want to find out what is in junk2.mat, junk2.mat is not there. Can you open junk2.txt? Yes, it is able to open. So this opens all the files. So if you want to open a variable, can you open a variable? Let us say who is there. There is a variable junk2. So can you open a variable like junk2? Junk2 has to be within this. So this will open a variable in the table form where you can edit the particular variable against save. So that brings up a variable editor. So that is also not required. So I am considering that particular, so I will open it again and again. So this open is also not very important. Edit is not important. Type is not important. Open is also not important. Let me see which. What is which? So help which. Okay. So if you write which, let us say you want to write a function sign. So it will tell you what is that function. So if you write which log, so it will tell you what is inbuilt function. Which, let us say, write fmin f0. So it will tell you this is a function, this is the path. So this is required, but it is not very important. Therefore, I will also delete this. So this is also P code, pseudocode, create a pre-pass pseudocode file. It is also not required. So in mem, so if you write in mem, it will tell you what are the functions in the memory. So these are the functions which is already there in the memory. You can clear it. So I don't want, this function is also not required for the beginners. So I shall also delete it. And makes file, makes will tell you when you want to convert C programs into M file, MAT files, sorry, makes files. So sometimes you have some earlier existing C programs that can be converted into makes files which can be executed. So this is considered to be important. So path is not important because this you can directly set it from the command prompt. Whenever you are writing very complicated routines, this path will be important, where you can add and remove path, just like the MATLAB path. So if you see path, it will tell you what is there in the MATLAB path. As I said, it will search for your M files, functions, etc. in this path. So using this path command, you can add path, you can remove path. You can use also path tool to modify the path, search path. Path tool is same as the path tool will give you the same thing as the GUI, okay, from the references. You can set path from this. So these are important only when you are interested to write very complicated functions. So what is rehash? It is actually related to the operating system. What it is going to do, it will rehash the path, except that it forces, we can see what is rehash. I have not used it, but it is a refresh function and file system caches. It is basically required for again clearing the trash from the cache memory. So this I don't consider important right now at this stage. So important Java packages into current scope. This also is not important because we are interested in the numerical numerical arithmetic right now. So echo is sometimes required when you want to echo the commands, and more is important. Diary is important. I have told format. So you can use format to set the output format. You might have seen while storing the numerical values in those text files, you have seen long and double kind of precision, but I want to change the precision. So you can use format. If you write format short or format long or format short e, you will find the echoing. That means the command prompt, suppose I want to write pi. Pi is an inbuilt function 3.145. So if I write format long, if I type pi, you see what is happening. It is giving the long. Suppose I can write format hex. If I write pi, you will find in hexadecimal form. So if I write just format, it will give you the inbuilt form, whatever I got. So you can change the format from this. So it will, so this will display the format as outputs, what outputs you want. All right. So that is format. Beep, it produces a beep sound. If you write beep, it will produce a beep sound if the speaker is available. So these all of them are important, except this beep will not be required for you right now, but it may require earlier in next. So then operating system commands. So cd for change directory, as I have done earlier, that I have cd, I will cd just like that. So if I write pwd, I am in this path, again cd to learn, it will go to learn. Okay, pwd again it goes. So this is cd. Then copy file, you want to copy a file or directory. This will not be required because you don't have to do it in the MATLAB prompt, but still you can see copy and move. It will just like the Unix and DOS commands, but you can easily copy and paste the files using your operating system. So this is not required. Delete also it is not required. PW I have already said. So directory, it will show you the directory. So it will show you the file attributes, whether read write permission is there or not. So each directory true if an argument is a directory. So if you are writing each directory, you can see it is a binary. The output is illogical. So it will tell you whether a particular thing is a directory or not. So this directory, you can see C colon MATLAB. It is not a directory. But if I write like this, it has to be always. So this is not the C is directory. Yes. So dot is a directory. It is directory here. Okay, but there is no other directory in this. But if I change here, if I write is directory dot learn 1, that means learn is there in this particular directory. You can see learn is there. So to find out a directory under this, whether it is there. Make directory, you can make a directory directly in the command prompt. Remove directory, you can remove that directory. You can get environmental variable. Then this will be called shell escape, just like in Unix. You can, using this, you can execute window commands. For example, I want to execute notepad, I can do so. You see notepad is open here. So using this I can use. So DOS commands are outdated, so I am not writing this. Unix commands also you can write Unix commands right there. So system, all executive system functions are there. So this all these are not, I am not interested in this right now, because computer tells the computer times. So it tells you whether it is Unix version of MATLAB or not, whether it is a PC version of MATLAB or not. So then there are some debugging commands which we will not be using right now, because debugging basically we will use our own method of debugging. So these debugging commands will not be using. Right. So these functions are also profiling, will not be using right now. So whenever you use, we will consider them. So therefore I am considering. So all these things I am deleting right now. So debugging M files, because we will develop our own method of debugging. So don't have to depend on this. You have to learn this. This is not required, and we will also use more our own methods of profiling. So we will use to our own methods to see the functions whether they are or not. So I'll just delete it. So these are the only important things which we'll look into it. So thank you very much. We have just started. We have understood what are the commands we need. Please go through them one by one once again in the lecture, and you be prepared for my next lecture. Thank you very much.